This series of programs on mathematics for electronics will help you learn ways to solve problems typical of those in electronics design and servicing. Electronics is a quantitative technology. That is, we need to know how far, how high, and how much in nearly every situation. The relationships of the quantities are often complex and not easy to express in ordinary ways. For these two reasons, you will find it necessary to learn and practice the procedures of mathematics, including arithmetic and algebra. Occasionally, you will apply math to problems which are typical of electronics. For example, you may have two loudspeakers using 8 watts each and two loudspeakers drawing 5 watts each in your 4-speaker setup. What is the total power required? Right. Of course, you may be able to do this sort of thing in your head or on scratch paper, but a little review and practice won't hurt. Most of these programs proceed rather rapidly. You may wish to repeat them 2 or 3 times. If a program, perhaps this one, seems easy to you, you won't need to repeat it. Even though you understand some arithmetic or other math procedures, however, you'll need a real facility in using them quickly and accurately, so a careful, thorough review is worthwhile. For example, what's the sum of +5 and -3? Yes, you'll learn about positive and negative or signed numbers later. You won't have much time in these programs, however, for extended practice, for it is assumed that you've previously studied arithmetic and need only a short review to refresh your memory. This is the 15th program in the series on mathematics for electronics. It is about trigonometric functions. You've heard of the mathematical field of trigonometry. From its name, you can tell perhaps that it deals with angles and triangles. A triangle, you know, is an enclosed geometric figure with 3 straight sides. It has 3 other features, too. What are they? Yes, of course, and these angles may be of several kinds: acute angles, right angles, and obtuse angles. Which of these is an acute angle? Yes. In electricity and electronics, we often deal with alternating current in reactive circuits. Inductors or capacitors in reactive circuits cause the current to get out of step or out of exact synchronism with the voltage. This is called being out of phase. We say there is a phase angle between the voltage and current, and to work with this phase angle, we need to know something about trigonometry. Trigonometry is partly based on right triangles. A right triangle has one right angle. Which of these is a right angle? Yes. In this program, you will review some of the things you learned in algebra, and most of it is similar to the material in a response-type program in an algebra series, so it may be quite familiar. To check your recollection, can there be 2 right angles in a triangle? Yes. A right angle is formed by the intersection of 2 perpendicular lines which form 4 equal angles. Mathematicians have chosen to say that a right angle contains 90 degrees. An acute angle contains less than 90 degrees, and an obtuse angle has more than 90 degrees. The 4 right angles formed when 2 perpendicular lines cross add up to how many degrees? Perhaps you remember the name of the longest side, the diagonal side opposite the 90-degree angle in a right triangle. It's called the hypotenuse. What do you think the 2 sides next to the right angle are called? Yes, the legs of the right triangle. Usually we designate the sides of a right triangle with lowercase letters, those corresponding to uppercase letters indicating the angle opposite that side. This means that if capital A and capital B are the 2 acute angles of a right triangle, small a and b are the 2 legs, or shorter sides. Capital C would then be the right angle. What would lowercase c designate? Right. If you've studied program MG7 recently, you will recall the Pythagorean theorem, which states that the length of the hypotenuse is the square root of a squared plus b squared. Another way to put this is to say that the square of the hypotenuse